Alright everyone, so for today's video, I have Mr. Alvarez in the background, so if you hear some noises, it's him, or me making weird noises. He's just staring me down this entire time. We're going to be doing some practice with the air analysis like we did class yesterday, or if you're watching this for 6th period, I guess you'll be doing it today. And then we're also going to be working on some area, but I also wanted to talk about one of the problems from the Desmos because I seem to get a lot of questions about the setup for it. So I figured I'd go over it instead of you guys just being confused. So it's the last problem of the most recent Desmos. It's where I'm playing basketball. So the question is, I'm practicing my free throw shot at local basketball center. So we're gonna take each line and we're gonna go through the information. The first thing is, if the height to make the basket is 5 inches above the rim, so we're gonna take that, we're gonna call this 5 inches. Then the next line is the rim is 120 inches from the ground. So if this is the point that we want to make the ball in, that'll be our topmost point. This is where the rim is. That means that from here down to the ground is going to be 120 inches. That means that this total distance is going to be 125 inches from the ground to our topmost part. And the next thing is, I'm 180 inches away from the center of the hoop. So we'll assume that this point is also at the center of the hoop, and I'm 180 inches away. We'll call this 180. So we're gonna measure the angle that I have to throw the basketball at to make it in. So when we're looking at this, we have to account for my height. So we're taking the angle from my arm, which means that when I'm shooting it, the angle created from my arm going on my shoulder is the angle that we're accounting for. So the distance from my arm, so like right here, to the ground, we're going to call that 56 inches. So we'll go up over here, and this is going to be 56 inches. So this is where I'm making the angle. That means this distance from the ground we're not going to use in our main equation, or our main diagram. We're going to call our hypotenuse this diagonal line here. Redraw that. So this is going to be from the basketball going into that topmost part, and we're going to be measuring this angle right here. So our distance from the hoop never changes, so we're going to keep this as 180 inches. But we have a change in our height. So initially we have from the top point that I want to make the basketball into to the ground is 125 inches. But because we're getting rid of the 56 inches from the ground to my arm, so I'm going to erase these. So we don't care about this distance from the ground. We're only caring about the distance from my arm to that topmost point. So this distance can be 125 minus 56, which is going to equal 69 inches. All right. So we have an angle that we're searching for, we'll call that x. We know the horizontal distance over here, and then we now know the vertical distance that is going to be needed for our setup. Since our reference angle is over here, we have the adjacent side, which means we're going to either use tangent or cosine, and we have the opposite side given to us. So because we're given the opposite and the adjacent, we're going to use tangent as our main equation setup. So we'll say tangent of x, our angle over there, is equal to the opposite over adjacent. We're going to sub in our values now. That's going to be 69 over 180. Now, in order to solve for that x, we have to use the inverse function because we have to cancel out this main function. So we're going to do tangent, inverse tangent of x is equal to inverse tangent of 69 over 180. The tangent's going to cancel out, and we're going to get that x is equal to inverse tangent of 69 over 180. We're going to plug that into the calculator. As a reminder, in order to get inverse tangent, we have to press the second button on our calculator and then press the tangent button. I'll get inverse tangent. We're going to plug in our ratio, and we're going to get 20.97 and a bunch of other numbers after that. We're going to round up to the nearest degree. So x is going to be equal to that, and since we're rounding up, x in the end is going to actually equal 21. I'm going to leave this up on the board so you guys can take a minute to look at everything. And then I'll actually relabel this distance over here in blue. That's our 5 inches. And then this distance from here to here, we'll call that 120 inches. So going through it once over, we have our distance from the point we want to get the ball to the rim as 5 inches. And then from the rim to the ground is 120 inches. I'm standing 180 inches away. And the distance that we're measuring the angle that we're measuring is from my arm. So we have to negate all of this distance down here, which is 56. That cuts out that same distance here, which is why we have to do 125 minus 56 to get the necessary distance over here. Once we found everything we need, we plug it into the tangent function because it uses the opposite adjacent side to the reference angle, and then we work our way down to solve for the angle, which is 21.